Hi everybody, welcome back to the Feynman technique. Today we're just going to be proving this identity right here using Feynman integration, or the Leibniz rule for differentiation under the integral sign. I got the idea for this video off of the channel Michael Penn. I'm not even going to link to the video because I'm sure you guys are all familiar with his channel. Just check out his channel and you can find this video on it easily enough. This is going to be pretty quick, but here we go. So this is a function of t, so we can take a derivative with respect to t of f of t just by calling it f prime of t. And then using the Leibniz rule for differentiation under the integral sign, we can take a derivative of this entire integral by taking the derivative with respect to t of the integrand. So let's see, that's going to still give us the integral from 0 to infinity of something. This first part will drop out. We will be left with a negative e to the negative xt times a negative x. So the negatives would cancel out, leaving us nothing but e to the negative xt dx. We will let u equal xt, therefore du is equal to t dx, so we'll put in a t there and a 1 over t. Alright, so now we have f prime of t is equal to 1 over t times the integral from, let's see, if u is equal to xt, we still have 0, and we still have infinity. Our t dx becomes a du, and our e to the negative xt becomes e to the negative u du. So that is going to be equal to 1 over t times negative e to the negative u from 0 to infinity. The infinity part will cancel out because e to the negative infinity is just 0. So that's going to be 1 over t times, times negative e to the negative 0, or negative 1, or just 1, so it's just 1 over t. So our f prime of t is simply equal to 1 over t. We're not interested in f prime of t, though. We want f of t. So we're going to go backwards by integrating. We're going to take the antiderivative with respect to t of f prime of t and 1 over t, giving us f of t is equal to natural log of t plus c. All right, now how do we get rid of that plus c? Well, we're going to have to refer back to our original expression for f of t. But we can't cheat by using this part. So we're going to have to find a nice value for t that we can plug into this to give us a good answer. Well, the obvious thing to do is to let t equal 1, because then we just have e to the negative x minus e to the negative x on top, or just 0. So the whole thing would be 0. In other words, f evaluated at 1 would be 0. So 0 is equal to the natural log of 1, which is 0, plus c, giving us c equals 0. So there we go. We've just shown that if f of t is equal to this, then it is also equal to natural log t. There you go. Hope you enjoyed that.